All right, so this one says suppose $9,000 is invested. So usually investments are um, exponential growth. That says A of T. And the principal invested is always the initial value. Is invested for T years at this given rate, compounded monthly. So the formula is going to be 1, whoops, 1 plus R over N to the N T. Okay, so I just put the formula on the screen and just notice that depending on what this value is, if they say monthly or quarterly, that that would change, right? So if it was quarterly, that would be a 4. If it was biannual, it would be 2. So just depending on what term they use, but we're using 12. Okay, so that's the equation. Of course, you could simplify this, and I can even just so we have it in simplified form. We could do that. So parentheses 1 plus 0.055 divided by 12. Um, and we're gonna press enter. So it's 1.04583, etc. So I think it's easier to understand if I keep it this way. But if we need to go to this other form, it's fine. Okay, so that said, that's part A. Part B, we're being asked to use the model to find the future value of the investment in 4 years. So that's just a matter of plugging in a 4. And you're going to do this with your scientific calculator. So I'm going to write it down, but then I'm going to go to my calculator. So I'm just going to choose to leave it this way. And we're going to plug in a 4 up here. And then we'll know what the future value is. Okay, so let me see if I can get a scientific calculator. And hopefully it's not too tedious to get the value computed. And I'm just going to put 48 because I can multiply that out. So in 4 years, This investment is going to be worth 11,209.06. 11,209.06. All right, now for part C, they say how long is it gonna take for this thing to double? So double is 18,000. Okay, so I need to figure out what is the T that's gonna make this double? My unknown is the T. If I divide both sides by 9,000, now I'm gonna erase some of this stuff because I need the space. If I divide both sides by 9,000, that leaves me with 2 equals. See, I think this is a good place to use the that other value. Is that what we want to do? Well, let's just leave it as is. It's a long decimal anyway, so it's a lot of it's a lot to write down anyway, so okay, so now what I'm gonna do, what I'm gonna do is kind of move that over a bit. Is I am gonna take uh I'm gonna take the natural log of both sides. I'll take the natural log of both sides. So what that allows me to do, what that allows me to do, on the left, I still have the natural log of 2. But on the right, it allows me to take this 12t and put it out in front. That's a power property times the natural log of 1 plus 0.055 divided by 12. And then what I'm going to do is I'm going to divide both sides by 12 and also divide by the natural log of 1 plus 0.055 over 12. So that's got to come over here too. 1 plus 0.055 over 12. We're almost there. I get to cancel out the 12s, cancel out the natural log piece. So just to simplify things, hopefully you're okay with me doing it this way. I can delete the 12 and I can delete this and I can delete that and I'm left with T. And what's T equal to? T equals this. Now, could put that in the calculator. Just to save time, I'm gonna let you go ahead and do that.